Find the rate of change of total revenue, cost, and profit with respect to time. Assume that R of X, C of X are in dollars. So let me find the rate of change of total revenue first, okay? So working with this orange equation, R of X, okay? I'll take the derivative of both sides with respect to t. So what's that going to be? dr dt is equal to derivative of 60x minus 0.5x squared, but the variable of differentiation this time is t, not x. So this is not going to be just 60 minus 1x. It's going to be 60 times dx dt minus 1x times dx dt using implicit differentiation. So let's plug in everything they gave us. What was dx dt? Dx dt is 20 units per day, and x is 25. So if I go ahead and evaluate that using a calculator, 60 times 20 minus 25 times 20, the rate of change of total revenue comes out to be $700 per day. Okay, all right, let's try the other one. Let's find the rate of change of total cost. So working with this other function, I'll circle this in green. Okay, I'm trying to find dc dt, and that's going to be derivative of 2x plus 10 with respect to t. And that is going to be 2 times dx dt plus 10 will just give us 0. So this will be 2 times, and they said dx dt was 20. So 2 times 20 comes out to be simply 40. So the rate of change of total cost is $40 per day. And for the profit, I'll just go ahead and subtract those two and say that the rate of change of total profit is $660 per day. Okay? That was way too short. How about I do one more? So, in a trend that scientists attribute, at least in part, to global warming, and a certain floating cap of sea ice has been shrinking since 1980. The ice cap always shrinks in the summer and grows in winter. The average minimum size of the ice cap in square miles can be approximated by A equals pi times r squared. So it must be a circle, huh? In 2013, the radius of the ice cap was approximately, all right, let's take a look at this information they're giving us, that the radius is approximately 771, and it was shrinking at a rate of 4.4 miles per year. So radius was changing. So say dr dt is equal to negative 4.4. Because it's shrinking, we must put negative sign there. It's asking how fast was the area changing at that time. They want us to find dA dt. All right, so let's find the derivative of both sides with respect to t. So left-hand side will just be dA dt, but the right side we have to differentiate pi r squared, and that's going to be 2 pi times r times d, you know what, I think I want to draw this multiplication dots, r times dr dt. And we did this one above, I think a number 4-ish. So this is something that we did in the other problem. So let's plug in everything we have. So I have my 2, I have my pi, r was given as 771, and dr dt was given as negative 4.4. All right, I'm going to go ahead and multiply all these out. 2 pi 771 times negative 4.4. And it comes out to be negative 21,315. And I don't think I typed up how to round here, so I'll just go it around to a whole number. It was decreasing by 21,315 square miles per year at that time. Okay, and that is the change in area with respect to time at that very moment.